Space Station event. My name is Lillian and I'm your host for this event. Today we bring two speakers to talk to us about Axiom Space Station, the first private space station. Our first speaker is Jason. Sorry, I don't want to get your last name wrong. As
There you go.
Jason has more than 60 years of experience in the aerospace and defensive industry and is currently a business development manager for Axiom Space. He's also the founder and chairman of the FinCOFI Public Benefit Corporation. Our second speaker is Simon Jenner. Simon's role is to research the Earth for the few amazing people who are qualified to go to space. With 2 missions launching per year to the International Space Station and then to Axiom Space Station, Simon is hunting for people with the right stuff to be an Axiom astronaut. Today, they will be giving us an overview of how Axiom Station is being built to support an evolving and diverse ecosystem of commercial activities in LEO. I'll hand it over to Jason and Simon.
Why, thank you.
Good morning, everyone. Hello. Okay, perhaps let me start with telling you a little bit about how Axiom came to be. So Axiom was founded a number of years ago by 2 founders, Mike Safradini and Cam Katharian, who were both very involved in the International Space Station project in their previous careers. Mike Safradini in particular was the program manager for the International Space Station, responsible for essentially everything to do with ISS, working for NASA for more than a decade. And they identified an opportunity that the International Space Station is growing old, is due for retirement in upcoming years. And we're expecting at the moment about 2028, the ISS is going to need to be deorbited and retired. We know that the ISS partners want to have a continuing solution in low Earth orbit, but their focus has shifted from low Earth orbit to the moon and then moving on from the moon to Mars. So there needs to be a space station, and there was no one else doing it. So hence Axiom Space is created. So Axiom is designed to be the first commercial space station operating and essentially continuing the services available on ISS, only provided through a commercial partner. Jason, do you want to talk through this one?
Sure. So this is just a very, very 30,000-foot view overview of all the things that we are designing Axiom Station to be able to facilitate. And one of the things we'll talk about over and over again is about the diverse ecosystem of customers, right? Whereas the ISS in general has been designed and operated the past 20+ years to address needs of government customers for the most part. What we're trying to do here is look at a more commercial-centric ecosystem of customers. So yes, government agencies will be core customers to the station, but we're also looking at private astronauts, which Simon will be talking a lot more about. We're looking at for researchers, manufacturers. We're looking for organizations, government and private, that are looking for space exploration, space development. We're also looking for customers in media and filmmaking, and any other commercial enterprises that, as we'll talk further in the presentation, will be doing cool stuff in low Earth orbit. Also looking at defense. I mean, defense is a big deal nowadays. In the US, with the Space Force emerging as a core or integral parts of the overall space economy, and similar organizations have been set up around the world. So for better or for worse, militarization of space is happening. So how can Axiom Station support those efforts is definitely something we're looking for. And services span all the different customers as well. So each customer has unique needs for services, and the derivative emerging markets, which we'll talk about, will have benefits for anything in pharmaceuticals, biotech, life sciences, 3D printed materials, new materials, and even some opportunities that we can't even imagine right now. So there's a lot of research happening that's leading to discoveries that nobody could have figured out 10, 20 years ago. So that's definitely going to be part of the equation moving forward with Axiom Station. So next slide. One of the questions we get, what's different between Axiom and a few other companies aspiring to build space stations? Well, we're the first. It's just a title, right? But in 2020, we did win an award from NASA to utilize one of the ISS's empty nodes. So we have the singular contract to actually deploy one of our first modules on the ISS, and that will happen in 2024. And we actually have a couple of cool videos later on in the presentation showing you actual hardware that's being built and tested as we speak. So we're not just fancy PowerPoint presentations, we actually have hardware being designed, developed, and built in the next couple of years. So next slide. And just a quick overview. As Simon mentioned, we were founded a few years back in 2016. I was actually employee 112 back in February of 2021, so 7 months ago, and we're growing really fast. So now we have 300 people. Most of us are actually in engineering, designers, mechanical, electrical, software, or all the disciplines. We've raised substantial private capital, so $150 million from private investors around the world. The NASA contract we mentioned was about $140 million. The first module goes up on the ISS in 2024. We have a module thereafter every year, with the final module being deployed in 2028, which gives us sufficient power and thermal capacity to become a free-flying space station. I think the next slide is a really cool video showing, well, the roadmap.
Almost there.
Yeah, almost there. The video is cool. But again, just a quick roadmap showing you what we're doing. So in the next 3 years, we are operating as a facilitator of private astronaut missions, which Simon will talk a lot more about. And we have a few of those already booked and ready to go, and a few others in the pipeline the next 3 years until 2024. But then 2024 is when stuff starts becoming fun. That's when we get our first module up to the ISS, second module in 2025, third module in 26. The power tower, which is that big tower you see the solar arrays, gets deployed in 2027. And that's what enables us to become a free-flying commercial space station. Simon, do you want to be the narrating voice for the video?
I can do that. So what we can see here is a really cool video demonstrating the construction sequence for our space station. So this is, as Jason was saying, this is demonstrating that it's being attached initially to the ISS, to one of the 4 docking ports. What we see here is the first habitation module, which is being installed. The second module, which is going to be connected, and we'll see this coming up very soon, is also a habitation module. So both of these have, let's call them beds, for lack of a better word, but sleeping quarters for 4 people each, as well as some laboratory facilities as well. And here we see the second one coming up. The second one, basically identical. Connecting on there. The arm that you see there is a new Axiom owned, we'll call it a Canadarm. All right, this next module that's coming up here is a specific laboratory module.
What you're seeing here is a fast forward of 4 years of evolution.
And that last piece that's just been installed there is very, very cool. So that is our Earth Observatory. So this is the window which our astronauts can go and spend some time in, very similar to the cupola, except many, many, many times larger. So comfortably, you can fit 3 people inside our Earth Observatory, their full bodies staring down at the Earth's surface. Uncomfortably, you probably squeeze in 6 or 7. And the last piece that's being installed there and that is deploying is our power and thermal center. So that includes our airlock as well. You can see that little black bit, which is our airlock. And there's our solar panels. So by the time that power and thermal module is installed, we're essentially good to go. We are able to be free flying from that point. So when the ISS is ready to be deorbited, we can then disconnect and move on being self-sufficient. And this is where I should have put those videos in instead of leaving these photos. But what we can see here in the top section is a piece. So this is actual hardware which has been constructed. Many space station companies have been spoken about over the years. We're the only one that's actually constructed stuff. Top left, this is a portion of our pressure vessel, which has been constructed in Italy. Top right is a piece of the window, which has been constructed for testing, pressure testing, as part of the Earth Observatory. And then what would be really cool is the propulsion, a test of our thruster system on the bottom there. So the thrusters that will guide each of our modules into their final positions.
There's a YouTube video linked to that, Simon, if you want to click it and if it loads. Oh, with the commercial before. Bless YouTube.
And why in 1 week?
I'm going to skip it. So my apologies to everybody who know about selling spices.
Yeah, we can say that the propulsion system is gaseous oxygen, gaseous methane, which is a really interesting choice. And you know, the primary reason we picked that is because our private astronauts and humans occupying the station, bringing with them the oxygen and food and supplies and stuff. Then we, as part of the life support system, recycle the air, and as we scrub the CO2, we actually produce gaseous methane. So the reason we picked this is because we'll be producing it in orbit. So it's a pretty cool utilization of orbital recycling, quote unquote, to produce fuel.
So I'm going to jump now into a description of a few of the different services that Axiom Station is going to be able to provide. First up is human spaceflight, and I'll talk a little bit more about that very soon. So we are sending both private and professional missions. So private being individuals that are self-funding their way to the ISS, and then in future to Axiom Station. This will be usually missions for about 7 to 10 days, but we do have parties who are interested in longer duration missions. We also have professional or national astronauts. So countries who are looking to send their own astronaut up to the ISS or Axiom Station. And this is where it gets really cool, because for a very long time, there has only been access to space for nations that are either one of the ISS partners or have a close geopolitical relationship with one of those partners. So we're in conversations now with a number of different countries that have never had that opportunity to go to space. And I can't announce any of them at the moment, but in the near future, we'll be very excited to share some of the details around countries which are going to have their first astronaut. I'll then talk very briefly about deep space exploration and the utilization of Axiom Station as a testbed, which of course, testing a lot of these technologies in low Earth orbit before they go to the Moon or Mars is a lot better than arriving to these deep space destinations and then realizing your technology is not quite ready, doesn't quite work. And then I'll pass back over to Jason. Jason will talk about some of the research and manufacturing available in low Earth orbit and the ways that that can change the future of humanity and benefit everybody. So human spaceflight, and this is what is exciting for me because this is my role. So as I mentioned, we are providing missions to the ISS starting in February next year. About 2 missions per year is what we're aiming for. That is a restriction by NASA initially until we have the Axiom segment up there, at which point, depending on how demand is looking, we can decide to rapidly increase the frequency of launches should there be a need for that. We're launch agnostic. So at the moment, we have signed up with SpaceX to provide the launch services for our first 4 missions. However, we are more than comfortable using any of the launch providers that are available in the market. As most people know, the only launch provider available on the market from US soil at the moment is SpaceX. But as soon as Boeing gets their Starliner vehicle up and ready, then that will be an option available to us as well. And then as we see other options in the future as well, we look to exploit that, that market. So why do our private astronauts choose to go to space? So there is no single bucket of people that want to go to space, of course. The people that I speak to quite regularly for upcoming missions have a wide variety of reasons why they'd like to go. For many, it's been a childhood dream. They have always been space nerds since they were very, very young. They didn't have a pathway or the opportunity to become an astronaut initially, so they went off and made their fortune somewhere else. And now that option has become available to them again. We've got some people who want to create a legacy. They know that the future of humanity is off Earth, and they know that it needs the pioneers to be starting to fly to space now in order to make it more readily accessible for everybody else. And for many people, it's about their philanthropy. So many of the people that we're speaking to who have the means to afford a ticket to fly to space are already contributing significant components of their wealth into their philanthropic endeavors. And they always have something very specific that they care about, be it research into cancer, as an example, or be it funding education and trying to inspire additional students studying STEM or STEAM activities. Here is a picture of our first crew. So our first crew is launching in February 2022. It's led by an Axiom commander. So our mission, all of our missions have an Axiom commander, which is a former NASA experienced astronaut. For our first mission is Michael Lopez Alegria. He is a world famous and a record holding NASA astronaut, holds a number of records for the number and duration of EVAs for a US citizen. He's also the second Spanish astronaut ever. Our pilot is an American by the name of Larry Connor, and we have 2 mission specialists on our mission as well. Eitan Stivi from Israel and Mark Pathy from Canada. So each of these gentlemen have a wide variety of mission objectives, and our team is working together with them to take up some research, to take up and to facilitate communications time so that they can speak to students, so that they can conduct some research on station, and basically live their lives over the 10-day mission exactly as other astronauts would. Very cool picture there of Michael Lopez Alegria out there in one of his EVAs. We've announced the first 2 members of our AX2 crew. The other 2 we've not announced yet. Peggy Whitson, most people would know her name. She's for a long time until Wally Funk went to space with Blue Origin. She was the oldest woman in space. She also holds EVA records and held records for being the longest duration in space for an American as well. And our partner is John Schaffner. John made his fortune through fiber optic cable installation around the world. But the stuff he does outside of that is extremely cool. He races with his wife. They have a racing team. They are also both quite well-known philanthropists, as well as athletes. They do a lot of extreme sports as well. Both Peggy and John are going to be conducting a large amount of genomics research on the station, so focusing on personalized medicine, which of course is extremely important. They'll be launching probably mid to late 2022. We're looking at future missions as well. Our AX3 crew is already full. That's going to be launching probably around April 2024. Our AX4 crew is what I'm currently recruiting for. That's going to be launching probably around September, October 2024. And then we're looking at launching a national astronaut mission, which we're calling the AXR5 mission, which will be late 2024 or early 2025. But of course, I'm still in conversations with people for future missions as well, for AX6, AX7 and beyond. All right, I'm going to jump now into some photos of some of the training that our AX1 crew has been doing. So they've been launching, or they are launching, as I said before, in February. They've started their training quite a while ago. They, as part of their training, went on a zero-G flight, where they got the opportunity to experience weightlessness for many of them for the first time. For MLA, obviously he's done that before, but you can still see on his face that he really enjoyed it. They conducted some training in the centrifuge to test their ability to withstand G-forces. What was very cool is we sent them on some survival training. So basically, we took them to Canada. We dumped them on the top of a mountain with a helicopter with a couple of guides, which are shown there. Pointed at a mountain far off in the distance and said, we'll pick you up there in a week. And they only had what they had in their packs to keep them alive, essentially. So it was a very interesting and amazing experience for all these gentlemen. Most of them had never done anything like this before. And it really brought the crew together. So this is something which we'll be doing for all of our future missions as well. Here is a photo here of MLA and Larry in the SpaceX Dragon simulator. So here they are practicing maneuvers to dock the Crew Dragon vehicle to the space station, as well as practicing their emergency maneuvers. So, of course, when they launch, I'm going to show you a few photos now of their mission. So they're launching AX1 mission on the Crew Dragon vehicle and the Falcon 9 rocket. They'll be going up to orbit, traveling at, or getting to 400 kilometers above the Earth's surface, where the International Space Station is, docking, and then they get to see these amazing views out the window. So everybody on this call has probably heard of the overview effect. One of the really important things that Axiom is trying to promote and our astronauts want to experience is the overview effect. For those that haven't heard of it, there is a reported feeling of wonder, a sense of all of the Earth's problems becoming insignificant when you look down and see the Earth without borders. And where that is important is when our astronauts come back down to Earth, they get to bring this changed worldview back. Our astronauts, when they come back to Earth, don't stop being Axiom astronauts. They get the opportunity with the new Axiom Astronaut branding to open up to their network and really expand their philanthropy and bring the experience that they've experienced in space back down to Earth. I'll put this really cool quote in here, which isn't necessarily related to the overview effect, but it's a quote from the Apollo missions. Oops, apologies. So we came all this way to explore the moon. The most important thing is that we discovered the Earth. And I want to briefly touch on our deep space exploration support. So as I mentioned earlier, we are providing a bit of a test bed with Axiom Station, so that as the nations who previously focused on low Earth orbit now turn their eyes to the moon, and then in future to the Mars and the planets beyond, there are a lot of technologies. We're not quite ready to go there yet. There are a lot of technologies that need to be developed and tested. It is much easier to be testing these technologies in a safe environment, in a space station in low Earth orbit, where you have a return time of less than a day in the event of an emergency, than it is to get to the moon or get to Mars and realize that this life-supporting piece of technology that you need doesn't work as well as you think it should. And you have a much longer and more dangerous return mission, or maybe you're stuck there without this piece of technology. So we are providing that support for some of our customers to test that technology in our station. Now I'm going to throw to Jason to talk a bit about the research and manufacturing opportunities.
Thanks, Simon. Great overview of the private astronaut aspects of our station. So before I talk about what we're doing as, what we see ourselves as infrastructure, I do want to talk a little bit about the ISS and how we're different. And I start with some of the realities of the ISS, which is cost. And the ISS has a budget of about $1.5 billion, which comes out of NASA to support operations and maintenance of the ISS. And then you also have about $1.8 billion just for transporting astronauts, supplies, and cargo to and from the ISS. It's a big chunk of money just for operating. And for the research that's facilitated, actually that's a very small chunk. It's about $50 million per year is funded from the ISS National Labs to sponsor all the cool research that happens on the ISS in life sciences, materials, physical science, etc. Bottom line is, it's a really expensive piece of infrastructure. It's critical infrastructure. It's been needed. It's done some amazing things, but it was never structured to be low cost. It was never structured to act in a commercial manner of things. And it's been heavily subsidized by the US government. Next slide, please. Uh-oh, did I lose Simon? Simon, do you copy? Oh, there we go. Thank you.
All right, a bit of lag on my end.
That's all right. And here I just want to accentuate that you look at these numbers, and most of the users of the ISS from a research payload perspective are either academia, civil agencies like NASA and others, and foreign governments. So you get the payloads from ESA and Jackson and the governments around the world. So most of the research has been funded or sponsored by academia or by government and or by academia. And a very, very small chunk has been what we call startups or SMEs, small to medium-sized enterprises. There's a trend which is encouraging. So there's a little bit of a doubling, I suppose, in the past few years up until 2020 for COVID. But again, most of the research and payloads in the ISS have been sponsored by governments. Next slide, please. So, what is the case for a commercial space station? And the primary case, before I even get to the economics, is, it's just a different charter. Whereas for the ISS, the government's role was to own the station, operate it, maintain it, and drive innovative things that are happening in the station. For commercial space stations, the role of government is one of many customers. So it's privately owned, privately operated, but the primary charter, as I mentioned, is facilitate applied R&D versus fundamental R&D and accelerate growth of LEO economy and commercialization. And it comes down to how do you fund it as well. Whereas ISS was funded by government/public funds in the order of $150 billion over 10, 20 years. Axiom Station, other commercial stations are being funded right now, at least through private avenues. So either by raising equity, raising debt, reinvesting some of your profits from operations the first few years, or even public markets. I mean, there's a lot of discussions the past couple of years about space companies going through what's called the special purpose acquisition corporation route to raise public capital. So it's just a different paradigm of how you raise capital and then the order of responsibility you have towards your investors to actually return a buck on their investment. The last but not least is how do you generate revenues? And the ISS really is not a revenue, was never designed to be a revenue generating machine. And the reason I have B2C here is because through companies like Axiom, private astral missions, yes, you could make some money off the ISS, but it was never really designed to provide those avenues. Whereas Axiom Station and others, we're looking at business to government, business to consumer, business to business, or even business to business to consumer as primary, secondary, and tertiary revenue streams. So it's just a different mindset that comes along with building and operating commercial space station. Next slide, please. And the times are definitely changing, and the graph on the top left shows a plot of all rocket providers the past few years and how costs are drastically coming down on a per kilo basis. Last I checked, on a per kilo basis, SpaceX is almost at $1,000 per kilo, which is it's an amazing price compared to historical price on a per kilo basis from legacy rocket systems. And you have big banks like Bank of America and Morgan Stanley and UBS projecting sometimes 2x, 5x, and 7x growth of the space economy over the next 10, 20 years. And the Space Force that was established a couple of years ago in the US, and several countries have mimicked, sort of carving out dedicated organizational infrastructure to support defense needs in space. For better or for worse, it's a good thing, because it means governments are now seriously looking at not just militarizing space, but ensuring that civil and commercial needs and requirements are satisfied and met through protection of the space ecosystem. And of course, it means more funding too, which is a good thing. Next slide, please. Here I wanted to talk about, what remains the biggest inhibitor towards low Earth orbit commercialization, and it remains cost. Even at $1,000 per kilo, you're still looking at very, very expensive tickets for the average person in the space. You're looking at very high costs for getting payloads to space. I mean, it's cheaper than it used to be, but still pretty high, given that the US and the governments are trying to pull away from subsidizing transportation and deployment of payloads in low Earth orbit. So, what cost is low enough? We don't quite know yet. All we do know is that as a function of time and as a function of launching rockets over and over and over again, you get what's called a learning curve, which makes sense. That the more something you build and the more times you fly it, the better you become at making it, the better you become at operating it, the better you become at making sure it's reliable and reusable, which is what SpaceX has been doing. So what these graphs show is that historically speaking, the reductions in cost follow what's called a learning curve of the more companies have sent rockets up into space over time, the lower the costs are coming down. So what that means is the more stuff we launch, more humans, more resupplies, more cargoes, the cost will keep coming down. Obviously not to zero ever, but if you believe Elon Musk, it's probably somewhere in the hundreds of dollars per kilogram versus thousands of dollars per kilogram. So an order of magnitude reduction, potentially even in the next 10 years. Next slide, please. And Simon looks at PAMs from the aspirational perspective, and I completely agree. I also look at it from an economic perspective, as I mentioned before, the more humans we launch into space, the cheaper it becomes to launch more humans in the future. So, some people argue, oh, why the billionaires get to go to space? And, it's a very unfair kind of paradigm. What does it say about society? And you could take that point of view, but I personally think it's quite myopic. I mean, if you look at the early aviation days back in the 20s, 30s, and 40s, it was expensive. And nobody except for very wealthy individuals could afford to fly back then. And through continual advancement and continual usage of aviation back then, and by the way, heavy government subsidization, prices came down steadily, over the decades to the levels they are today. I mean, even in the 50s and 60s, flying was pretty expensive. People still used ships to cross, from Europe and England to America back in the 50s and 60s. But eventually, by the 70s, 80s, 90s, and obviously today, prices came to where they are right now, affordable for the vast majority of humans. And it's the same thing for the space industry. The more humans we send that go to space and pay the exorbitant prices, the industry will become better at facilitating lower and lower, by the way, safer and safer transportation of humans to and from space. So PAMs, the missions we're doing, yes, they're by wealthy individuals, but it's part of kickstarting this future of everyone having access to space. Next slide, please. But beyond just driving costs down for humans to get to space, it also drives costs down for payloads and stuff. And these boring graphs, what they essentially want to show is that right now the only real markets for low Earth orbit are either U.S. government and R&D and defense. And as I mentioned before, and Simon talked about private astronaut missions, of wealthy individuals who can afford to go to space. Other markets like making biotech products or advanced materials manufacturing or space tourism for the average person, those things are just unattainable. It's just too expensive. But if you click one slide forward, as time goes by and you launch more humans, you launch more stuff, what other markets now become economically viable where products like biotech or advanced materials made in space are now affordable and can compete with terrestrial equivalents. So think of a semiconductor that, if made in space, has a 25% performance advantage. If it costs 1,000 times more, nobody's going to buy it. But if it only costs 50% more, there's potentially a market for it. So what these graphs show, and if you click one more, please, Simon, what these graphs show is that as time goes by and we launch more stuff, more and more markets will open up, and more economic valuable will be more and more economic value will become realizable for the space economy. Next slide, please. So what are some of the LEO markets today? As I mentioned, we have private astronaut missions and governments. You break that down, legacy markets are Earth observation, communications, GPS, military assets. Emerging markets, you got private astronaut missions that we talked about. You got LEO broadband. I mean, SpaceX Starlink is already doing that. You got Telesat, you got Amazon, all looking into deploying very large LEO broadband constellations, and you got space debris remediation. So Astroscale is one of my favorite companies in the industry right now, doing exactly that, because it's a big problem, but it's also a economic opportunity. Click one slide. Yep. As Axiom becomes the first commercial space station, and there's potentially more commercial space stations, what are some new markets that could emerge? And I call those blue ocean markets. And orbital servicing, assembling, manufacturing. So think of refueling assets in space, whether military or commercial assets. Think about taking smaller components of satellites or infrastructure, bringing it to orbit and assembling it in space, and therefore building even larger structures. So think about the James Webb telescope that's about to go up in the next few months. That magnificent piece of engineering that most of the money and engineering effort was spent figuring out how to get that thing to deploy, because it's so big, you had to make it deployable, and therefore had to spend a lot of money and effort to figure out how to do that. If we had in orbit assembling as a capability, you would send it all in pieces and build it in space, and it might actually end up being cheaper in the long term as opposed to $10 billion later. I can't wait to see those pictures, by the way, and so should you. And manufacturing, I mean, there's advancements by a few companies, namely Main in Space, which is the most famous one, now part of Redwire, was demonstrated making things in space through 3D printing methods. And so think about, do you need to actually build satellites on the ground, or could you build structures in space through 3D printing processes and machinery? And some of the things we want to talk about in the next few slides is manufacturing of products. And as I mentioned, it could be biotech, could be materials, could be advanced manufacturing of electronics or other components. And I call those space to earth goods. So is there an advantage by making these materials in microgravity? And it turns out there are. There are many advantages of making things without gravity being part of the equation. And so as long as those things become cost competitive with terrestrial component counterparts, then we will have a market for space to earth goods. But there's also space to space goods. So as I mentioned, instead of making things on Earth and sending them to space, if you have the materials sourced from either the moon or asteroids, or in the case of Axiom Station, recycling some of the human-generated CO2 to make methane, you have those things in space as commodities. You can start making things in space to be used in space. And tourism and orbital cities, and that's part of the future we're trying to eventually get to as well, which I'll talk about in the last slide. But we do believe in space eventually being accessible by most humans, assuming the prices come down, as we hopefully foresee in the next couple of decades. Next slide, please. So here, I'm not going to read through all these, but just stare at these possibilities. And as I mentioned before, for all these industrial processes in the second column, and the products in the third column that those industrial processes generate, gravity has an effect. And so what we're postulating here is, you take away gravity, and by taking away gravity, you facilitate absence of convection or absence of cementation or containerless processing. All these things become new or enhanced industrial processes. Then how would you go about making enhanced or potentially new materials that lead to enhanced or new components, better semiconductors, better alloys, more robust proteins, etc., that then end up being space to earth goods or in space manufactured goods that would have a benefit for all of us back on Earth, whether it's for just biomedical components, devices, or even solutions for climate change. So anything to do with enhancing power generation or power storage for materials in microgravity that could have potential long-term dividends when it comes to combating climate change. So, this slide, I think, I want people to stare at this and kind of think about, what's something I could potentially do in my research to drive innovation in materials manufacturing. So, next slide, please. And again, some examples of products people are already working on. So optical fibers, there's been a lot of developments and demonstrations of developing high quality optical fibers, namely ZBlang, which has already been done and shown to have much higher performance in terms of fiber quality than ZBlang developed on Earth. So because you're doing a microgravity, the fiber pulling mechanism leads to much less non-uniformity of the fiber, therefore high quality transmission of light. And alloys, 3D printing, colloids, bioprinting, one of my favorites, which still in the early phases, but there's been experiments, demonstrations of printing artificial 3D organ samples in the hopes of making high fidelity, custom, fit organs for us back home in absence of gravity. And then, as I mentioned before, question mark, right? What other products, industrial processes could be developed to go derive products with high utility for use back on Earth? And the next slide, please. And going back to some of the ideas for space-to-space goods, and here's some examples of that, right? So making orbital structural components like very large trusses to build, either larger stations or larger satellite systems, or shielding panels. So think about taking lunar regolith and converting it into 3D printing stock and applying that as sort of a layer of plaster or lunar concrete on the outside of structures either on orbit or the moon itself to protect against radiation. And so these are just some ideas of products you can make in space from in-space resources to facilitate a variety of applications and enterprises, both for commercial and government usage. Next slide, please. And to enable this, and when we're showing that pretty video of the station being constructed, that second to last module, which Simon correctly called the laboratory, is what we're calling the Axiom Lab for research manufacturing. It's dedicated volume of 40 cubic meters plus a bunch of real estate on the outside to facilitate all those biomedical, biotech, materials manufacturing applications that I talked about before. And so it's being designed specifically to cater to those markets and help accelerate, multiple of those potential space to Earth and space to space product lines. Next slide, please. So second to last slide, and then we can go to questions. But from a philosophical perspective, you think about what's the point of all this, and the point is, we're presented with a grave opportunity here of changing how we do industry, for not just for the sake of making a profit, but for the sake of making products that are better and help us solve problems back on Earth. And the more we do that in the context of microgravity, but then also in the context of trying to solve actual problems for how to live and survive on the moon, Mars, asteroids, and beyond, as we come up with those solutions, there's going to be direct derivative value for back home. So, and NASA's proven that over and over again over the decades, things that were designed to solve XYZ problem for how to land, lunar lander, has paid dividends. I mean, a lot of the things we take for granted today, like our cell phones, are derivatives of technology developed by NASA to solve problems back in the 60s. So it's a matter of feedback, doing research, and developing new products and new processes that will pay dividends for us back home, but also for our future in space. Next slide, please. The last slide. Here's a little bit of an aspirational vision, but our CEO, Mike Safdini, has not been shy about saying, our ultimate vision is citizen space. So in 2028, when we become a free-flying space station, is not the end. We already thinking about what's the next generation of stations, and I'm being cute by showing 4 stations, but really what I'm trying to say is in 2030, there's no reason why we can't build more than 1 and more futuristic versions of our current design station. And eventually, if things will go well with the economic expansion in low Earth orbit and beyond, and the reduction of launch costs and the proliferation of humans and infrastructure in space, there's no reason why we can't see the first quote-unquote sitting space within our lifetime. And I'm not talking about millions of people in space. I think that's a bit too futuristic, but I could definitely see 1,000 people living and working in space in the next couple of decades. So I think that's it. I think we'll have some time for questions. Thank you very much for your time, everyone.
All right.
I see Edward has his hand up.
Yeah, hi guys. Thanks for that talk. Very good. I just wanted to ask specifically to New Zealand as a nation trying to maybe partner with Axiom, what sort of stuff would we need to bring with us to Axiom, and what sort of stuff do you provide? So like we'd have to bring like our own research, but are we paying for a seat and then you're going to sort out the astronauts and send them up there, or do we have to go through our own training, our own design of spacesuits? Do we have to bring our own food? Sort of like where is that gap between what Axiom provides and what we need to organize ourselves?
Yeah, I can handle that one. So if we're talking about human spaceflight, Edward, then Axiom takes care of all of it. So if there is a New Zealander that wants to fly, be it them flying individually or be it a New Zealand government wanting to fund a national astronaut, then basically we'll take care of everything. We conduct all the training, utilizing our own facilities as well as NASA and other international partner facilities. We work with our launch provider, depending who that is for the particular mission, for the pressure suit. All the food is taken care of. And then we work with the individual or the nation to work out what type of research they want to be conducting in orbit. And that's when we go through the process to make sure that it's flight certified, and we get it up there ready to go, be it launched prior to the mission or be it launched with our mission with the astronaut. Does that answer your question?
Yeah, that's brilliant. Thanks.
Now, I'd like to add just a little shout out to the payloads team. You don't need, I mean, we'd like you to bring an astronaut, but you don't need an astronaut per se to send research. So we do have customers that will send just payloads, and that's definitely something we want to do. So if there's a cool payload concept or research you want to do, there's no reason why you can't propose that, and we could try to accommodate without needing an astronaut to babysit the payload per se. So.
Okay, yeah, thank you very much.
Rowena, I think you're next. Good to see you here.
Yeah, hi. Thank you for a fascinating talk. I really enjoyed that. And as I'm someone involved with space medicine, my question is, what are you doing in terms of medical screening guidelines and fitness to fly assessments? And is that sort of a longitudinal process across the training? Thank you.
Yeah. we do a lot. And our goalposts are changing all the time. So it's worth noting that whilst there have been private astronauts that have flown to the International Space Station before, they've done so with Russia through Roscosmos. And this is the first time that NASA has had private astronauts flying to the International Space Station. So we do a whole gamut of screening and testing to ensure that the private astronauts are fit for flight. And if we identify anything, then we can suggest some corrective measures. Dissimilar to what many of the astronaut selection and astronaut recruitment processes go through, where they would screen out people that have medical issues. Our hope is to fly as many people as possible. So if we identify something which is a flight contraindicator from a health perspective, then we're going to work with the astronaut to try and make sure that that's addressed so they get the opportunity to fly. As for what type of tests are conducted, they are continuing to be, the list of tests is continually changing and continually changing and is repeated multiple times throughout the private astronaut's journey pre-flight. I feel like that's maybe a bit of a satisfying, but an unsatisfying answer for you, Rowena. Eric.
Hi, great talk. What we were wondering, what's the total crew size for when you have a free flying station, and how do you build up when you have those additional modules?
So when we get to the point where we are free flying, we will have 8 beds on station. But of course, similar to what's happening in the ISS today, there is capability to have more astronauts up there. They'll just be camping, attach themselves to other areas. Now, this is only to the point where we become self-sufficient and free flying. So as Jason said, our station doesn't stop there. Once we get to that point, we more than likely are going to be continuing to add modules. But that just means that we have sufficient facilities up there to do as much as and more than what the ISS currently does from a research and manufacturing point of view, as well as having the life support systems available to support as much or more astronauts.
And can I also clarify, so if you're still attached to the ISS and you just have kind of like that one habitation module, and then you're adding 2, when you have that one habitation module, how many astronauts are you allowed basically to have up there
While you're attached?
While you're attached?
That is a very good question. I'm going to say I don't know. Once we've got our own module up there, our intention is to have as many missions going up there as possible. We're flying missions of 4 people to begin with, but once Starliner is flying, then of course that might be 5, or if Dragon changes its configuration. At some point, we are going to be having our station permanently crewed. I don't know, we don't know when that is yet, but so it'll be permanently crewed, plus having additional short-term visitors come along as well. So yeah, a great question, and I don't know the answer to that.
No worries.
Thanks.
Carl, I think you were next, or Carl Bridges, I think you were next.
Hi, thank you. First of all, Simon and Jason, really enjoyed your presentation. I'm quite new to this, I suppose, this community. My name's Carl Bridges, and I work in the field of human factors, focusing on human behaviour, cognition, and human interaction with complex systems. And I'm always thinking about the what ifs in any field of operation. And Rowena asked my first question, so I'll cut to the chase. I mean, we kind of anticipate that when people are going to go up to into low Earth orbits, that they are, they are going to get that sense of awe. And but one of the things that crossed my mind was that they were up there for you mentioned about 7 to 10 days, I think. And And I'm always thinking of the what ifs. And I'm sorry to put a bit of a dampener on this, but what actually happens if somebody gets up there and they just want to come home, or they need to come home for whatever reason? Are they stuck there for 7 to 10 days? And I suppose this taps a little bit into, I suppose, the selection and training procedures, is that if they are stuck up there for 7 to 10 days, how are they going to cope with it, especially if they do want or need to get home? I'm just wondering, is it too early to talk? Is it too early to ascertain what measures you've got in place at this stage, or has this been well thought out and well planned already?
No, I can answer that. So as part of the testing, the pre-flight testing, there is a fair bit of psychological testing that happens. Obviously, we don't want a situation where one of our astronauts is up there and it says, "I'm done, I want to go home." In that situation, we would have them speaking back down to the ground, speaking to the psychologist or the medical team to try and, whatever the concern is, to try and address that rather than ending the mission early. If it is an emergency situation, emergency health situation, be it mental or physical, and it can't be addressed and treated on station via remote medicine or via the crew that are up there, then we always have the option to end the mission early and come back down. So when any mission heads to the ISS, their vehicle, of course, stays up there and is there as their lifeboat. So they always have the opportunity to come back down to Earth. Not ideal, of course, but that is an option available to them.
Okay, thank you very much.
Pleasure. And then other Carl, your turn. If you're talking, Carl, you're on mute.
Oh, apologies. Hi, can you hear me?
We can hear you, thank you.
Hi, guys. You're talking about manufacturing in space and a lot of interesting stuff with semiconductors and optical components. Can you tell us about any partners or any interested institutions you are working with or who are interested in doing this sort of stuff?
Numerous. I mean, dozens of universities and dozens of small to medium to large companies around the world that are interested in doing, have done things on the ISS, continue to have interest to do things in the ISS, and want to do more things on Axiom Station. Because really the possibilities are limitless, and I can't stress that enough. And a lot of us, myself included, I think we've barely scratched the surface, because a lot of the research has been mostly on the fundamental side. Now we're getting into the interesting things of doing applied research and looking for real prioritization of just fundamentals into real manufacturing in low rate, eventually full rate. When it comes to biotech stuff, some of those things take time because you have to go through regulatory approval processes, and specifically for biotechnology, you got to go through clinical trials and then FDA approvals here in the US, and that takes some time. But going back to your question again, yeah, we're working with dozens and dozens of universities and small to medium to large companies in the US, around the world, doing a variety of things in life sciences and materials. And as far as, yeah, I mean, we're always looking for more ideas. So if you or anyone in your research cycles has an idea, we'd love to hear from you.
Okay, thank you.
Yeah, I'll drop my email in the text box. Anybody, if you have any questions or ideas, let me know.
Wonderful. Do we have any more questions? Lillian, I see your mouth moving, but I don't hear anything coming from you. Oh, now I hear you.
Oh, hello. So there's a question in the chat box, if you don't mind answering that.
if the ISS is modular, why doesn't NASA just replace each aging module as needed? And I have an answer. Simon, you can also answer if you like, but it goes back to what I was showing earlier, right? NASA spends a lot of money operating and maintaining the ISS. And it's not just about aging modules. It's about, are you running this as a research laboratory? Are you running this as a commercialization / incubator of commercial products and enterprise, which eventually pays for itself, which is what our model is. So quite frankly, NASA wants to stop spending money on owning, operating, maintaining a station, and they want to spend money on the moon. They want to spend money on Mars and beyond, which is fine. I think that's great. That's what we need as a civilization, and you keep pushing forward. And that's why NASA is really bullish about helping companies like ours. And they recently put out the commercial LEO destination proposal effort to further fund more aspirational commercial space stations, because they want to see an evolution of commercial entities taking over low Earth orbits, and then NASA can just become a customer of those stations, along with other government entities and along with the rest of the commercial ecosystem. So they just want to get out of the game of having to pay for maintaining and operating it. Question about fatigue life. I mean, that's just part of our design. You know, right now, from a purely a structural perspective, so you know, think about leaks, think about cracks, think about the modules staying attached to each other with sufficient pressurization. All that lifetime is about 30 years. Now, would we have to make some upgrades to some of the smarter subsystems like life support, avionics, networking? Yes, those things will need to be maintained, and we'll design those to be, you know, what's called modular, open, sustainable architecture. But the structure itself has been designed to survive 30 years.
Yenkai, looks like you've got a question.
Yeah. Thank you for coming. So I noticed in your slides, you got in Axiom 1 and 2, X1 and 2, you showed that there's a commander and pilot. Could you guys go through why you have both a commander and pilot, and I guess what do they do differently?
Yeah, sure. So the commander is an Axiom employee. Their role is to ensure that the customers on board have the safest and most productive flight and mission possible. So the commander and pilot both have roles in the ascent and descent to and from the station, piloting the spacecraft. What do they do differently? Both of them can operate the launch vehicle if necessary. A lot of the functions are going to be automated, but also there's some stuff that needs to be done manually as well. Both of them are trained to do so. Fundamentally, both of them could be called the pilot, but the commander is the one that's in charge of the mission.
Okay, thank you for that.
No problem. And Edward.
Yeah, hi, just wanted to quickly ask about how you expect to work with the space agencies when they are your customers. They're obviously used to having quite a lot of control. Do you think you'd give them that sort of control over, especially looking after their own personnel, or do you guys sort of regulate that all yourself?
I can give you a NASA perspective, and then Simon, you can chime in with maybe an international space agency perspective. But you know, from NASA's perspective, that's why they gave us a contract, because they want to make sure that we're instilling into the design some things they care about. And of course, if it's things they care about but make no sense, we will fight back, which, you know, I guess we have in some cases. But you know, at the end of the day, NASA wants to become a customer of many, and that has to come to the reality that they won't have control as they traditionally have had for infrastructure they've owned, operated, and maintained. Pricing will be what we're calling commercial rent or lease pricing for using the station. In some cases, NASA may come with specific requirements for specific hardware and specific systems, which will come with a different price tag. But in general, as NASA is migrating away from leading the charge in low Earth orbits, comes along with it the new paradigm of they're just a customer amongst many, which comes with minimum control and, for their benefit, much better pricing. All comes down to money, right? They want to save money so they can go do cool stuff on the moon, Mars, and beyond. Simon, if you want to chime in, if there's anything to say about International Space Agency.
Yeah, let me add to that. So our job as Axiom is to provide the infrastructure in space, and the infrastructure we're providing is what our customers need. Now, our customers, we want our customers' feedback as to what type of facilities they want in orbit, and that can be those customers, space agencies, or commercial partners, or private individuals. We want to be making sure that we're addressing the needs of what our customers want to be doing in space. So from that perspective, of course, we want their feedback for the type of research, the type of activities they want to be conducting in space. And then when it comes to the missions themselves, again, regardless of who the customer is, private, individual, commercial, or government, we want to be understanding as early as possible what their mission objectives are, and then putting measures in place to achieve as many of those mission objectives as possible. Cool. I hope that answered your question, Edward.
Yeah, brilliant. Thanks.
Wonderful. And Yankai again.
Yeah. Thank you. Okay. Oh, wait. Lillian, did you want to say something?
I said your one should be the last question.
Oh, okay. And yeah, so so I'm a biologist, and I noticed you guys talk a lot of pharmaceuticals and biotech, and so I guess a number of us are trying to propose scientific experiments, biological experiments. Do you have advice, since you guys probably have seen a lot more experiments, do you have advice on building a business case for biotech or pharmaceutical, biotech, some pharmaceutical experiments?
I kind of gave in between the lines earlier that for business case or pharmaceuticals in space, you got to take the regulatory process for what it is. Just because it's a space product doesn't mean you're going to bypass the regulatory process. If anything, it may take it a little bit longer. I mean, we are working on figuring out a standardized process whereby approving something made in space for bio applications takes the equivalent amount of time as it does to pass through the regulatory process back on Earth, not longer. Definitely not shorter, because that's just not possible. Doesn't matter how good the product is. But my advice would be, when you're structuring a business case for a new idea, make sure you have sufficient time in there to account for the clinical trials and the approval processes required from regulators in the respective nation from which this product is being developed. Otherwise, at this juncture, like I said before, a lot of it's just blue ocean. So no idea is silly. I think any idea is worth consideration. And we have 3 people on my team specializing in life science and biological, biotech, etc. So if you have any ideas, happy to hear them and talk about what we could do either on the ISS next few years or on our station starting in 2024.
Thank you.
I think Carl's got another question.
Hi, following on from Yankai's question, I'd like to ask when, I mean, you talked about being in talking with small companies, but when will it become feasible and affordable for small companies to be easily able to conduct experiments with Axiom Space Station?
Yeah, it depends on the payload size, really. I mean, for the next few years, we're leveraging ISS National Labs, which of course subsidizes transportation to and from the ISS. So the cost really is just a matter of designing and building a payload that meets the safety and interface requirements into the ISS. Now, in 2024, when we have our own station, things will change a little bit. We're going to charge rent for payloads. It's not very much, but it's something. And transportation will also have to be something that the payload sender will have to pay for, and that's on a per kilo basis. But if it's just an experiment, there's no reason why it can't be small. Depending on what kind of experiment you're trying to do, some things require significant size, but some things don't, in which case it shouldn't be that expensive. And at that point, it's going to be a matter of the cost to design and build the payload, integrate it, pay a small rent to Axiom, and then pay for the transportation of the payload to the space station through a commercial launch provider. So it just depends. The bottom line is it depends on the size of the payload in the experiment. Size doesn't matter when it comes to the costs.
Okay, thank you.
Okay, I think that will be the end for our Q&A session. Thank you, Jason and Simon, for the insightful talk and how Axiom Space is creating the future for humanity.
Thank you. It's a pleasure to have been here.
So we would like to thank our partner, Auckland Space Institute, and thank you all for coming. And we'll see you at the next event. Thank you.
Wonderful. Thanks, everybody.